this work, we saw that autistic participants made more jerky, that is less smooth arm movements compared to non-autistic controls. Moving in a jerky fashion can feed into difficulties with tasks like handwriting or riding a bike. However, at present it is unclear why autistic individuals would move with increased jerk. Increased jerk can be an indicator of fundamental differences in the way that speed is modulated as a function of the curvature of a movement trajectory, but can also be due to moving atypically slow or fast, or decomposing long fluid movements into a series of shorter sub-movements. In the current study, we asked 21 autistic and 19 controls to draw shapes on a touchscreen device while we recorded their movements. We observed that compared to controls, autistic participants moved in a more jerky fashion, and this was particularly the case for what we refer to as high angular frequency shapes such as ellipses, triangles and squares. We also saw that autistic participants decomposed shapes into a greater number of sub-movements. We also saw that autistic participants moved faster compared to controls, and this was especially the case for ellipses, triangles and square shapes. And we saw that autistic participants exhibited a steeper gradient between speed and curvature, meaning that their speed slowed down more dramatically for curved portions of movements. So why do our autistic participants move in a more jerky fashion? Is it the sub-movements, the speed, or the speed curvature gradient differences? Well, we observed that for spiral shapes, for autistic participants, speed was the most important predictor of jerk, with sub-movements being second most important and the speed curvature gradient being third most important. However, for other low angular frequency shapes, we saw that, yes, speed was the most important predictor of jerk, but this time gradient was second most important and sub-movements was third. And finally, for the high angular frequency shapes like triangles and squares, we saw that again speed was most important, but now sub-movements were second most important and gradient was third. So overall, we conclude that speed is the most important predictor, but predictors of jerk in autism vary depending on the shape of the movement trajectory.